Okay, so I'm going to fill in pages 9 and 10, the bottom of 9 and then 10. So I asked for you guys to give the molecular formula of the above compounds. So assuming everybody filled these in, which I think you did, probably great job at, then for each one of these, you're going to go ahead and count up the carbons and the hydrogens. So for B, we have 3-ethylpentane. Ethyl is 2. Pentane is 5. So we have C7H, and then you can spend a lot of time counting up all these hydrogens. 2, 4, 6, plus 3, 3, 9, 10. So I have 2, 4, 6, 16. C7H16. If I ask you this question on an exam, like a multiple choice, are these two isomers? I would really just focus on the carbons at first, and then zero in on the hydrogens. So let's do this real quick for each one. 3-ethyl, 2-methylhexane. Hex is 6. Methyl is 1, so 7, plus ethyl is 2. So you have C9. All right, D, 3-methylpentane. Pentane is 5, methyl is 1, so you got C6. All right, E, 5-sec-butyl nonane. Okay, sec-butyl is 4, nonane is 9. So 9 plus 4 would give you C13. Excuse me. F, 4-isopropyl octane. So octane's 8, isopropyl is 3, so you got C11. G, 2-methylhexane, so you got C6 plus 1, C7. H is 2,2-dimethylpropane, so you have 3 plus 2 methyls would give you 5, C5. I is 2,4-dimethyloctane, so octane is 8. In methyl, 2 methyls would be 8 plus 2 would be C10. So you see, I'm just taking the bare bones carbons, because you can spend a lot of time trying to count up all these hydrogens. J, 5-ethyl, 2-methyldecane. All right, so decane's 10, methyl is 1, ethyl is 2, so this is C13. All right, so from this, the number of carbons, E and J, would be isomers. C, where else? Oh, C7, G, sorry, I'm going to do a different symbol, square. And then C11. Okay, so we have, it looks like A and F, B and G, and then E and F. No, E and J. Sorry, ignore that. Since these are all straight chain alkanes, it turns out there's a formula that has the form CnH2n plus 2. So like C9, H would be 2 times 9 plus 2, 20. So you can count up C. Let's do 2, 4, 6, 8, and then 1, 2, 3, 4. So 8 plus 12, that gives you 20. So that works out. So this formula applies for straight chain alkanes. Key here, alkanes, okay? And if you're asked if something's isomer, if you have isomers, I would first and foremost count up carbons and not waste your time on hydrogens. If it's a straight chain alkane, then you can come up with this formula. So C6H, 2 times 6 would be 12, 14. C13, 2 times 13 would give you 26 plus 2, 28. So then you can go ahead and fill those out, and it's not that big of a deal. 2 times 11 is 22, plus 2 is 24, C7. 2 times 7 is 14 plus 2, H16, so that matches up. And you can count these up. And if you find yourself, if you're going crazy in your hydrogens, like you're getting an odd number of hydrogens, it may be that you violated the 4 bonds to carbons rule, which sometimes happens. So just keep that in mind. This formula will show you if they're not matching up. Okay, C5, H2N, so 2 times 5 is 10 plus 2 is 12. H2N plus 2, so that would be 20 plus 2, 22. 20. 2 times 13 is 26 plus 2 is 28. Okay, so that's how you complete that. So, then we're going to go on to the next page. Oh, while I'm thinking of this, for cycloalkanes, they have the general formula CnH2n, because remember with cycloalkanes you lose 2 hydrogens. I hope you can see this. Kind of a little blurry, but I'm doing my best. Okay. Name the following compounds using IUPAC rules. Okay, first and foremost, with IUPAC, you're going to find the longest continuous chain of carbons. It may not always be written left to right, because these organic molecules can move around, right? Like when we built them with models. Okay, so this is going to be 1, 2, 3, 4, 5, 6, 7, 8. 2,4-dimethyl octane. 2,4-dimethyl. Sorry, this is octane. And go ahead and hit pause and try to name the rest of these. And then you can start again. All right, this guy is 2,2-dimethyl butane. This one is, it's tricky. You have to go around the corner. 1, 2, or 2, 3, 4, 5, 6, 7, 8, 9, 10. That's good old decane. Old man decane right there. He's a sneaky one. Okay. Now, numbering this one. This old man decane's a real stinker. And when numbering, you can start at this end or you can start at this end. And we're actually going to start numbering at this end. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be, so on the 3rd and the 5th carbon I have a methyl, and on the 7th carbon I have an ethyl. So ethyl comes before methyls. So it's going to be 7-ethyl. Three, 5-dimethyl decane. Okay? So your listing is not in numerical order. It's always in alphabetical order, and we do not alphabetize according to dye. All right, over here, this one was pretty straightforward. So I have 1, 2, 3, 4, 1, 2, 3, 4, no matter which way I number, 4, and that is T-butyl heptane. Okay, and this last one, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, here's another stinker, right? This is old man nonane. So we got nonane. And I'm going to start numbering closest to my substituents. So this is 1, 2, 3, 4, 5 in, and this is 1, 2, 3 in. So I'm going to go with the 3. So this is a methyl here. This is an isopropyl here. This is an ethyl. So ethyl's going to go first. 5-eth, ladies first, right? 5-ethyl. I'm just a little flap happy tonight, I think. Okay, and then isopropyl. 4-isopropyl. 3-methyl. 9. Hope you can read that. All right, that's the fill-in lecture, and I will see you guys next time.